Okay, so now that we reviewed some fraction work and some arithmetic, now let's talk about solving equations and formulas. So this material can be found in R2 in terms of practice, and basically how to solve an equation. You essentially are, or an inequality for that matter, is you're playing the golden rule. What I mean by the golden rule is whatever you do to one side of the equation, you have to do to the other. So often what we do is we're trying to get x by itself, right? That's the goal here, and what it's equal to. And so we start by collecting like terms to one side and the other like terms to the other. So we can see that this term has an x and this term has an x. This term doesn't and this term doesn't. So it doesn't really matter what side you combine them on. Often we combine the x's over to the left and the non-x stuff to the right. But essentially what you're doing is playing the golden rule. So what I'm going to choose to do is add 5x to both sides. Whatever I do to one side, as long as I do it to the other, I'm going to do it vertically here, I'm safe. While I do that, I can be adding 11 to both sides. So basically there's my golden rule. 3x and 5x, that gives us 8x. The 11s will cancel out. Don't forget your equal sign, right? The 13 and 11, that'll combine up to 24, and negative 5x and 5x cancels out. So basically we've built what's called an equivalent equation by playing the golden rule of doing the same thing to both sides. At this stage, to get the x by itself, I will divide both sides by 8. Here the 8's will now cancel out, leaving us with x by itself. 24 divided by 8 would give us 3, and there's basically our solution. The idea is if I was to come back up here and replace the x's with the 3, then I would have something that's true. So you can kind of get the feel for that. 3 times 3 would give us 9, minus 11 would give us negative 2. Over here, 13 take away, well, 5 times 3 is 15. 13 take away 15 would give us negative 2 if we were checking it. So everything checks out. We're good to go. All right, so that is basically how we solve an equation. What makes things more difficult is there's more going on. In this case, we have some parentheses. In this case, we have some fractions. But ultimately, what we want to do is play this golden rule of adding and subtracting the same thing from both sides. So when we have more complication, what I suggest you do and highly encourage you to do is simplify both sides as much as possible. Over here we simply distribute, so we get 3x minus 6. Don't forget your equal sign. On the other side we distribute the minus sign, which effectively changes the signs. If I combine like terms, over here there's no like terms, but over here 5x take away 4x is an x, plus a 6. So at this stage of the game, what I've done is I've changed this complicated guy into something more like this dude over here, where I can actually just kind of see what kind of balancing act, what kind of golden rules I want to play. So I think, again, collecting all my x terms to the left, I'll subtract that x from that side. Whatever I do to one side, I do to the other. While I do that, I'll add 6 to both sides. And so there's my equal sign. Over on this side, we're left with 2x. The 6's cancel out. The x's cancel out on this side, and 6 and 6 is 12. Do a quick division by 2 to both sides, and we have our solution, x equals 6. And again, if we were to plug that into the original equation, we get a nice true statement. All right, what about fractions? Well, depending on how strong or what you like to do here, you can play the golden rule by just doing all the fraction work that we did here. But what I like to do with the power of this equation, remember, I can do whatever I want to both sides and be okay. So what I'm going to choose to do here is to actually find the LCD, or what's commonly known as the lowest common multiple, right? And in this case, it looks like it's going to be 12. 3 goes into 12, 6 goes into 12, 2 goes into 12, and 4 goes to 12. So that's our lowest common denominator. And so what I'm going to do is I'm going to multiply, because again, I can do whatever I want as long as I do the same action to both sides of the equation. So I'm going to multiply both sides by 12. Doing a distribution, right, this turns into 24 over 3, This turns into 24 over 6, right? We're just basically multiplying fractions. This turns into 12 over 2. Don't forget your x. Forgot my x over there. And then 12 times 3 is 36, all over 4. And because I found something where everybody divides into, 24 divided by 3 is 8x. 24 divided by 6 is 4. 12 divided by 2 is 6. And 36 divided by 4 is 9. So I basically have cleared my fractions, and I'm back to doing something that is, dare I say, relatively easy. Playing the golden rule from this point, I subtract 6x from both sides. I'd add 4 to both sides, and I get 2x equals 13. Do a quick division, and we get our solution of 13 halves. So when I see an equation with fractions in it, my game plan is to find the LCD, play the golden rule by multiplying that to both sides, distribute that out, simplify your fractions, and now we're back to something that's a little bit easier to work with and to see. Alright? In the next stanza, things get a little harder because we not just have one variable like we did up here, but I actually have two. And so we're being asked to solve for y. And over here we're also being asked to solve for y. So same idea, what we're going to do is play the golden rule until I get the y all by its lonesome. So over here, right, here's the term with y in it, so I'm going to keep it by itself, and I basically want to get rid of the 3x on this side. So I will subtract it. Again, playing the golden rule, I got to do that to both sides. So on the left hand side, what remains is negative 4y. We still have our equality. And then over here, be careful, right? This is a 12 and that's a minus 3x. They're not like terms. So the best I can do is to rewrite that as negative 3x plus 12 or 12 minus 3x, however you want to see that. So we've started to isolate the y. To get y by itself, I'm going to divide by negative 4. Be careful here, right? We're dividing everybody by negative 4. The negative 4's cancel out, leaving us with y by itself. And then over here, see this for the two fractions that it is. I have negative 3 over negative 4, so we have a 3/4 x. I have a positive 12 over negative 4, which turns into a negative 3. And so there, right, unlike up here where I can actually find a number, right, here we basically just have our y in terms of another letter because we're solving a formula. And it's, you know, we can at the very least just get y by itself. So same idea for letter B. I'm trying to get this y right there by itself. Well, using the same idea here, I have a fraction, so my first move is to multiply both sides by the LCD, which in this case is 3. On this side, we'll end up with 3a. Over here, the 3's will divide out, leaving us with 2x plus y. To get this y by itself, it's as simple as subtracting 2x. So we have y left on this side. And again, be careful because this is a 3a and this is a 2x. They're not like terms. So the best I can do is rewrite that as 3a minus 2x. Or stated another way, y is 3a minus 2x. Alright? So there's basically a review of how to solve linear equations. In this section, R2, you will also find some things with relation to solving linear inequalities, but the good news is it's very similar to what we just did. You keep playing the same. Let's simplify, play the golden rule of adding and subtracting, right, and get the variable isolated by itself. The only difference in an inequality, you'll end up with a greater than or a less than statement rather than an equal statement. Okay, so hopefully that was some good review of the golden rule of equations. Please go and hit R2 for more practice and to practice more ideas and get more information back. Alright, that's it for now. I'll cut away to some more videos to talk about R3 information, and I'll see you in some videos coming soon. Talk to you later.